Hello my dear students, how are you? I hope you all are very fine and very good. Last day we have learned about the chapter force and which is called also Newton's laws of motion. So I think in last class we have learned about all the forces related, okay, different kind of forces and also the three laws, Newton's laws and also the inertia and other things. So today we are going to learn the very important and interesting topic, that is conservation of linear momentum. I hope you all know what is momentum, already discussed in the last class. Okay. So today we will do some concept about it and after that we will do some numerical. Okay. So let's start about, first of all, what is momentum that you all know? Momentum is all about the mass and velocity, and numerical momentum is mass into velocity. And is it a scalar or vector quantity, students? Yes, you are right. You are always very serious. Okay. Now, momentum, what we denote by P, which is also equal to m into v. And thus, moment is a vector quantity. Why I am telling it again and again? Because it is very important in numerical. Why it is vector and how this vector is related to solve different kind of concepts in numericals, you learn it. Okay. Now, our theme is the conservation. Now, what is conserve? Conserve we all know, na? So anything which is not changing with respect of time or which is not changing, which is remain constant. Like we all know the conservation of energy, right? We know na? Energy can't be created, can't be destroyed. So this is the laws of conservation of energy, that we know energy can't, it can be transferable to another thing, another energy. So same way, conservation of linear momentum. Linear what means? Which moves in a straight line, right? Now why we are mentioning here linear? Because later on in next chapter we will get to know that there is another kind of momentum is there, which is angular momentum. Okay, that's why now in this here we are going to do linear momentum, correct? Now, first of all, suppose we are taking one simple case over here. What is the case, sir? Suppose an object of mass m1 is moving with a velocity u1. Correct? Very simple. Another object of mass m2 is moving with velocity m2. So, sorry, u2. Okay. The mass of second object is m2 and it is moving with velocity u2. Now, can you tell me that in which condition they will collide after some time? Whether this velocity should be equal? Now, I am giving one simple example. Suppose if a police want to catch a thief and police is running behind the thief, so whose velocity should be maximum? Whose velocity should be greater? Police or thief? Yes, the police. So here the same thing is happening here. We think that the object m1 which is moving with velocity u1, that u1 should be greater than u2. Then only they will collide. Okay. So suppose after some time they are colliding here. Okay, they are both of these objects are colliding here. So do you think after collision the velocity will remain same? Definitely not. Okay. So after collision, suppose its m1's velocity is becoming v1 and m2 velocity is becoming v2. Correct? Now, what is happening there, sir? See, it is the collision part, correct? It is the collision part. And what is this part? It is the before collision part. Before collision part. And it is the part is after collision part. After collision. Okay. The point is, will you tell me one thing, sir? Here, before collision, what is their momentum here? The object m1 is moving with velocity u1, so their momentum is m1 u1. Here its momentum is m2 u2. Here after collision its velocity becoming v1 and its velocity m2's velocity is becoming v2. So here the momentum is m1 v1, here the momentum is m2 v2. Now here if I talk about what is the total momentum, it is m1 v1 plus m2 v2. That is before collision. And here what is the total momentum? That is m1 v1 plus m2 v2. That is the total momentum after collision. So let's see whether this collision, what is happening there. So now the first question is, during this process, is there any kind of external force you are applying or any kind of force is coming there? Yeah, yes, definitely not. So no external force is involving there, correct? Now, But here we have to check one thing, sir. During collision, like suppose during this is the two objects, so it is colliding here. It is colliding this way. Okay, it is colliding this way. So now while it is colliding here, now Newton's third law will come there. Correct? Because we know when it is colliding there, this object is giving a force to that object, and same this object will also give another force, that is reaction to that object. So here action is reaction is involved here. So in that case, if this object is giving a force F1, if this is giving a force F2, so here according to Newton's third law we can write F1 equals to minus of F2 because opposite and equal. So minus of F2. F1 is the force which is giving by M1 object to M2. So here you can easily write that M1 A1. So it as F1 is the force of M1. So according to Newton's second law, you can easily write F1 equals to M1 A1. Second, so here also you can write F2 is equals to M2 A2. Now A1 is the acceleration of M1. Correct? Now, so instead of A1 you can write V1 is the final velocity of M1, isn't it? And U1 was the initial, like before collision the velocity of M1 is U1, after collision the velocity of M1 is V1. So here A1 instead of A1 is going to write V1 minus U1 by delta T. Why I am writing here delta T? Because here in few cases we have seen that in impulse we have studied, right? Impulse is when a larger amount of force are acting in a very shorter period of time. So here when the collision is happening, you can see the collisions, any kind of big collisions is happening between a very shorter period of time. So that's why I am using here delta T. You can use T1, T2, anything, no problem. But here just to show that part, we are going to be denoting here delta T. Now M2, here A2 is the what is the final velocity of M2, that is V2. What is the initial, that is before collision velocity of M2, that is U2. So here you can write V2 minus U2 by delta T. Why delta T? See, both of these collision time, the collision time of both objects will definitely be same. Correct? Now delta T is cancelled. So you can write M1 V1 minus M1 U1 is equals to minus of M2 V2 plus M2 U2. So again you can easily see M1 V1 plus M2 V2 is equals to M1 V1 plus M2 V2. So what is that? It is the total momentum, you can say total momentum after collision. And what is that? It is total momentum before collision. So it is clearly seen that when there is no external force involved in any kind of collision or any kind of linear moving object, in that case their linear momentum will be always same. So it can also be written as mv summation of mv. If we take it here, suppose if both of these things we take it, suppose if it is we are taking it as a final momentum, right, or final momentum or momentum after collision, and here it is we are taking an initial momentum, that is momentum after before collision. So if we take it here, it goes to 0. So we can see that the total momentum before collision and total momentum after collision is coming 0. Sum of them is coming 0. So we can write sum of P is always equals to 0 while there is no external force is involved. Correct? Now, sir, can you do it in calculus form? Yes, definitely. How? We know from Newton's second law F is equals to ma. Correct? F is equals to ma. And also another formula we know, sir, F, and how we have got this? We know that force is nothing about is the rate of change of momentum. So what is that momentum denoted by P? So F marker equals to dP by dt. As we all know, F is all about the vector quantity. So dP vector by dt, F marker equals dP vector by dt. So this thing we always know, right? Now, here while we have started this topic, I told you that here there should not be any external force. And Newton's second we have learned that this force is nothing but it is the one external anomalous force is applied. Correct? So in that case, F external is coming to 0. That means dP by dt is coming to 0. Correct? Now when the derivative of any quantity is coming 0? Why? The quantity is itself a constant quantity. So here when you can P is equals to constant. So here you can clearly see in calculus form also we have seen that the total momentum P is coming constant. That is constant. What does it mean? That is conserved. Conserved means before collision and after collision both the momentum is conserved. So this is the way how you learn that the momentum is conserved for a linear object which is moving in linearly. Okay. So this is the theoretical portion. Now we are going to do some theoretical example. Like suppose in birthday or any kind of occasion, we always blow some balloons. So if you release one, suppose a balloon is there, and if you release it suddenly, what happens? It started moving like this, right? How? See, in that case, we tell you, and this is the balloon. Suppose this is the balloon. Suppose, okay. Now you tell me, in that case, when it is tight, okay. Now in that case, what is its momentum? Is there any velocity? No, sir. Mass is there, okay. Mass is there, sir. But is there any velocity? No, sir. So what is its momentum? Is 0, sir. Correct. That means before releasing, the momentum of the balloon is coming 0. Correct. Now, while I am releasing it, so air is coming out in this way. Correct. Air is coming out in that way. That means the air is having a velocity in this direction. Okay. Now velocity is there. You can take the mass of air. You can take or what are the things gases are inside the balloon. That is also you can take. But the point is, it has a direction, sir, in that direction. Correct. It has a direction in that direction. In that direction, the momentum we are getting. Correct. But before this thing, so momentum was 0. So now the point is, in which direction the balloon should move, that its momentum is coming 0. Yes. So balloon should move in opposite direction. So that we know, I told you in first case that momentum is a vector quantity. See, this is how important I told you now. Momentum is a vector quantity. So if it is coming in that direction, to resolve it to come, momentum is coming 0, it should be in opposite direction. Correct? Now, see students, this is one example only I showed you here. But sir, in numericals it is not minded that this type of things will only come in. Now, what are the things may be involved in numerical? I am just showing you. And after that, you will also give some more examples. Now, for these things, I am just showing one very simple thing. Suppose M1 and M2, both of these are coming opposite to each other. Correct? Both of these are coming opposite to each other. U1 and U2. So, in that case, what will be there? In that case, your initial momentum, please concentrate very carefully. In numericals, you all know, no? But the basic thing, this direction, these vector things are very important. For these things, you do very silly mistakes. Okay. Now here, if we take this side is positive, suppose, so M1, U1 must be positive. But sir, it is as coming 0, so it will be M2 minus of U2. So here, the initial momentum must be M1 U1 minus M2 U2. This is one case, sir. Okay. Now after collision, see, it will be given in the question paper. If after collision, if it happens the object is moving in that, suppose M1 is moving in that direction and M2 is moving in that direction, then according to our previous sign convention, like in that direction we have taken positive, in opposite direction we have taken negative, so that in which direction they are giving in the question paper, accordingly you will do that which one V1 will be positive and V2 will be negative. Okay. Now another example is that sometimes it has been found that they will give you in such case that M1, M2 both are coming either in any direction, no problem. Now you got to know that in which direction will take positive and negative. So either it is opposite or same direction, no problem for you now. Now after that, if they stuck together and moving with a common velocity, okay, it may happen now. Can you give one example of it? Yeah. Think I am giving you 20 seconds. Very commonly, okay, how many of you are going by bus in school? Yeah. Suppose you are running behind a bus and you suddenly jumps to the bus and then bus and you both are going together, na? So in that case, what is happening? Yeah. So it actually happening in our practical life also, okay? So in that case, what will happen, sir? In that case, see, while you enter to the bus, okay? Now, whatever the speed of bus is it changing? Do you think that it has changed? It is definitely changed, but the mass of the bus is that much big according as per you, so you don't feel it, but there is definitely be some changes in it. So in that case, suppose this is the your bus and this is the mass of bus, okay? So now here the momentum will be m1 m2 into v. So it is your initial momentum m1 u1 plus m2 u2, and it is your final momentum m1 plus m2 v. And by this you can easily find out the whatever they want. Okay. Now, sir, is there any, okay, as I told you, I just have a very good example in front of you. What is this, sir? So this is a you can see it is a showpiece or anything, but in physics it is very conceptual thing is there. Okay. You probably definitely see these things in principal's chamber or any of your coordinator or HOD's chamber. So what is it, sir? So you can see there are some marbles are there which is tied by things and they are just touched. Okay, you can see they are just touched, but they are not connected to each other. But very interesting thing now I am going to show you. See, if I take it there, okay, and just see how nicely it is there. Now what is happening, sir? It has just clicked there and suddenly the ball is coming out from that portion. Is there anything is involved? Yes, sir. Yeah. It is the laws of conservation of linear momentum only. See, when you have taken out this ball, okay, when you have taken out this ball, the ball is having a mass, and you can see these all balls are in same mass. Okay. Now, when it is just touching this, the second ball, its velocity is coming almost to zero. Okay. Now, but whatever the momentum it was having, the whole momentum is transferring through this ball, and after that ball, at the last ball, nothing is there to resist it. So, by the same velocity it is coming out and it is going the exactly same distance from there. Okay. Now, you may say, sir, as the momentum is conserved, now why after some time it is coming to rest? It is due to, you can see the energy and all friction is there and air friction is there, sound energy is being produced. Okay, due to these things, energy is getting less, and due to this is coming to rest. So I think you got to know that what is the things are involved in here. Now another most important thing, whose father is there anyone whose father is are in army or any kind of defense? Or okay, fine. Yes, I can see so many students. Very good, very nice. Okay. Now, why I am asking it? You may ask you further, or you have seen in TVs or in different movies that when anything can be fired by a big rifles or anything, always the rifles put in your shoulder, or if they don't put it in the shoulder, and if you put it there and it is going in the backward direction. Why it is going like this? So it is also very important logic is there. What is that important logic, sir? Suppose this is one rifle. Okay. So now initially you can see the bullet inside the rifle. So there what is the momentum? Both of these are having the momentum is zero. Right. So now after the collision or after the firing, the momentum should also be zero. Correct? Now when the bullet is going in that direction, when it has been fired and it has started moving with velocity v with small mass m. Okay. Yes. Already I told you about the balloon that I have told you that is the same example. Okay. So if the bullet is going in that way, it is moving with the momentum v1, suppose. So as the momentum was zero earlier before the firing, so after the firing the momentum should be zero, right? So the gun which is the bullet which is moving in front, the gun should be moving backward direction so that their net momentum should be 0. That means here this momentum must be equal and opposite to their momentum, as their earlier or initial momentum was 0. So here we can write easily that capital M and capital V, that is the mass of gun and mass of recoil, which is called the recoil velocity, okay, which is equals to the, as why it is, because both of them are moving in opposite to each other. So from there we can easily find the recoil velocity of gun. It is so easy. Now another example I am giving you. After that we will do some numerical. I think in Diwali many of you have blast crackers, okay. So now in crackers, for all the crackers, suppose this is the A1 cracker, this is one cracker, okay. Now what is the momentum now? The momentum of it is 0, correct? Now after blasting, can you tell me that the remaining part or the ashes and all the things are moving in one particular direction or different directions, or in the all the directions? Yeah, very good. So after these things, they are moving in different. Why? Same thing, sir. Here, see, that in that case, what is the difference between? No difference is there at all. Here, the object, the bullet is moving one particular direction. So the rifle has to move in just opposite to the same direction. But here, the particles are moving in random directions. So the other particles should also be moving in random directions, so that the total momentum of this after collision should be 0. Correct? So this is the thing all about the sorry, part of the theoretical part. Now as you have all you are all having the PDF part, and I hope few of you have solved those problems, and now few numericals right now I am going to do. First of all, yes, I got one numerical question number 3. Okay, fine. So all of you please read this question. It is there in front of you. Okay. So here the question is, there is a balloon, okay. Suppose mass is 15 kg and one tie is there and a man is just hanging over it. Suppose I am drawing, and the mass of this man is 5 kg. Okay, and one word it is mentioned, that gravity free space. That is very important, because gravity free space means here you cannot take the weight and all gravitational acceleration, nothing you can take. That means you assume that it is happening in the space, correct? So few words you have to very carefully have to check. Okay, the velocity of the balloon, if man starts climbing the balloon with velocity 10 meters per second with respect to velocity. That means, that means for the question we have understood one thing, that both of these were static before climbing it, correct? That means there is no velocity at all before thing. That what does it mean? That before collision or before starting the man climbing to the balloon, the velocity of both of these was 0. That means the momentum was 0. Fine. Now, if the man climbing in upward direction, okay. Now again I am telling one thing. The man is going in upward direction and their initial momentum was 0. Correct? The man is going to upward direction, their initial momentum was 0. Correct? That means if the man is going in upward direction, in which direction the balloon will move? Very good. The balloon has to move in definitely in downward direction, so that their net momentum will be 0, as their initial momentum was 0. Correct? Now here, if suppose the velocity of man is v1 or bm, suppose I am taking, and the velocity of balloon is vb. Okay, v stands for here balloon. So their initial pi is equals to pf. Correct? Initial momentum is equal to final momentum. So initial momentum was 0. Final momentum is 15, that is mass of balloon. Okay, which, first of all tell me which one will you are going to take positive, the velocity of man or velocity of balloon? Okay, I am taking the velocity of man upward as a positive. Okay, upward as a positive. So if it is positive at the balloon, this is going downwards, so the velocity of balloon you have to take negative, correct? And plus, and this is going up, so it will be 5 Vm, correct? So it is 0 equals to minus 15 Vv plus 5 Vm. So you can easily see that Vm is equals to 3V, correct? Got it? Fine. So it is one relation that we have got. Now second, we have seen easily that the velocity, if man starts climbing the balloon with velocity 10 meters per second with respect to velocity. With respect to means definitely we have studied so many times. This is all about the relative velocity. Now here both of these are moving towards each other. That means their velocity is opposite to each other. So in that case, the relative velocity must be plus, right? So here you can easily see the another relation equals to 10 Vv equals to 10 by 4. So Vv equals to 2.5 meter per second. So velocity of balloon is coming 2.5. So let's see which option is here correct. Option A and B both are 2.5. Yes, but here one thing is mentioned, that option A 2.5 down, option B 2.5 up. So it must be 2.5 down, correct. So option A is the correct answer. Good. Now next problem is that, please read the question number 10. Okay, so next question is there are two rock, okay, an object flying in air which moving with a velocity of 20I plus 25J minus 12K. Okay, this is the object moving with a velocity of this, correct? Now this object breaks into two pieces with a ratio of 1:5. So there is an object which moving in the air, and after some time it breaks into two pieces, and one piece in two pieces in such a way that the ratios become 1:5. So suppose the smaller piece, suppose m1 we are taking small m, and the bigger piece m2 will be 5m, correct? Good. Now then the smaller mass flies off with a velocity of 100. The smaller mass, that is v1, as we are taking, v1 is equals to 100 I plus 35j plus 8k. So these are the you need to find out v2, that is at what speed, after braking, at what speed the bigger object, bigger piece will move. Okay. Now what is the total mass? The total mass you can take 6m, right? So initial velocity will be 6m into this v, correct? So if you multiply it, it will be 120 I cap plus 6 into 25, 150 j minus 72 k into m. So this is the initial momentum. Now what will be the final momentum? First of all, what will be the after braking? Okay, after braking, what is the momentum of v1 or m1 object? Okay, let's find out. So it is p1 is equals to m1 v1. So that is m into 100I plus 35j plus 8k, correct? Now let's find out, speed of v2 is equals to xi cap plus yj cap plus zk cap. Okay, now what will be the p2? P2 will be m2 v2, that is 6 into this, right? 6 into 5 into x, as m2 is equal to 5m, so 5 into x, 5xi plus 5yj plus 5z k. Okay, so this is what we are getting. So now we know it is simple. P initial momentum is equals to final momentum. So you know initial momentum with respect of I, the coefficient of I was 120. So in final momentum also the coefficient of I must be 120. So in P1 we are getting 100. So here, but here 5x, what it should be 5x? See, yes, it is 120, 100 we are already getting because PF is nothing about Pi is equals to PF is to P1 plus P2. Okay. Now P1 is your 100i, correct? M is common in everywhere, so don't worry about it. So 100 is 100i is there, but here what should be the x that it will become 120? So it must be 20. So 5x must be 20. That is x is 4. So you can see in that option only option A it is given 4i plus 23j minus 60k. So it is the correct one. Now the point is that as it is in one option only x, the value of x is given 4, that's why we have correct. We have not done the other process. So it is the easy trick. Okay, without doing it also directly you can find out. Directly by just to find out the coefficient of I, you can easily find out. It will help you find while there the options are different. But what would happen if there would be the similar option? Like suppose in option A it is given 4i. Suppose in option B is also it is given 4i, or j and k components are different. So in that case you have to do it the whole process. Instead of P1 you will write the whole thing. Instead of P2 you will write the whole thing. Then you must add this P1 plus P2, and then after adding you just compare the coefficient of I, coefficient of j and coefficient of k, and then this way you can easily find out the value of x, y, z. So hence if you find out the x, y, z, you can easily find out the velocity of M2, correct? So this is how we will do the numericals. I hope you understood the very basic numerics related to this topic we have done. Now next in your paper, in your daily practice paper, you can see there are 30 to 35 numerics are there that will be homework. So please do it, and after doing it, if you have any query, next day we are going to solve it. Okay, students, thank you. Have a good day.